Alright guys, today we're going to talk about triangles and circles. If you remember our previous lesson, we talked about quadrilaterals and circles and how not all quadrilaterals worked and how they had to be cyclic, and we talked about the properties, which ones would work, and we did a few constructions and a couple of problems dealing with angles. Well, today we're going to look at triangles and circles. Now, all triangles will work, and we're specifically going to look at what happens in acute triangles, obtuse triangles, and right triangles. So I'm going to come back and add to this in a minute. Before I do that, I'm going to go to my construction tool. So I want you to construct these as well. And I'm going to start with an acute triangle. So here I have acute triangle. And I'm just going to name it triangle ABC. And I'm going to do a construction that we're very, very familiar with. We have done the perpendicular bisector so many times at this point, but that's what I'm going to do. I'm going to find the perpendicular bisector. I'm going to do side AB first. So that means I'm going to put my point on A. I'm going to move my pencil so that it's more than halfway. And I'm going to make that large semicircle arc. Move my point over to B. Do the same thing. And we know that the line that passes through those two intersections is going to be, goodness, my iPad is not being very cooperative. Let me redraw those real quick. Okay, there we go. Let's get rid of that. Anyway, so the line that's connecting these two, goodness gracious, there we go. Haha, I'll get it in a minute. It's going to have to be close enough. There we go. It's our perpendicular bisector, and we know, we talked about, that means that from this point to both A and B are equidistant, and that this is a right angle here. Okay, so that's a perpendicular bisector. Well, there's this lovely property that says if I were to construct all three perpendicular bisectors of all three sides of a triangle, something special happens. Now, because I don't like a mess, and my iPad doesn't seem to like me most days, I'm going to construct two of them. So I did AB already, so I'm going to do the same thing for BC. Now, it doesn't matter, you can do AC if you'd like, but I'm going to do BC. So that just means I'm going to take my compass and do the same thing I just did. Now, notice I did change my color, so feel free to change your color, your highlighter, whatever. I'm going to go put my point at C. Again, I'm going to make sure that my pencil is more than what I feel like is halfway. And then I'm going to do my construction here. And move that over to B and do the same thing. So we can see, didn't make that quite big enough, did I? Okay, let me put it back at C and fix that. There we go. I needed them to intersect twice, and that top one on the right didn't quite intersect. All right, so again, I know that the connecting points from through these two intersections, there we go. Again, that's that red line is a perpendicular bisector to side BC. Now, I could go ahead and do the other side, but as you can see, my construction's already a big mess. Now, what I want to talk about actually is where those two perpendicular bisectors intersect. So I can see, there we go. I can see that they intersect right there. That's where my blue line and my purple and my red line meet. And if I were to draw the third one, it would also meet at that point. Well, that point is a very special point. As a matter of fact, that point, we're going to come over here and write it down, is called the circumcenter. The circumcenter is the point, is the intersection of the perpendicular bisectors in a triangle. And what makes it special is it also happens to be the center of the circle that is circumscribed about the triangle. Remember, circumscribed, we wrote that down on our notes on Monday. Circumscribed. Now here's going to be the true test to see if my iPad really likes me now. Okay, so what that means is if I take my point and I put it on that intersection, and I take my pencil and I put it on any three of the points, I'm just going to do B since I'm closest, I should be able to draw a circle, hey, so that the circle goes through all three vertices of the triangle, just like when we did the square and the trapezoid the other day. Again, it's circumscribed because the circle is outside of the triangle and each vertex of the triangle passes through the circle. So we can see that obviously that point is special. It's the center of the circle so that it's circumscribed. But what I want to point out today is that the circumcenter lands in different places depending on what kind of triangle it is. So we just did an acute triangle and we saw that the circumcenter was inside the triangle. All right, we saw that the circumcenter was inside the triangle. Let's look at an obtuse triangle. Okay, so we're going to, again, hope my iPad decides it's going to let me today. I'm going to actually refresh that page. And now I'm going to draw an obtuse triangle. I'm going to have to be very careful because I might run out of room. We're going to see here. Maybe not. I want to make mine just slightly obtuse because I'm restricted to the screen. You guys have paper and it's not as bad. Okay, so I'm going to do the same thing. I'm going to draw my perpendicular bisectors to these sides. So again, I'm going to grab my compass. I'm going to do the exact same construction. So I'm going to start down here. Well, let me go ahead and label these so it's not as confusing. Oh, here. So let me do that. So we're going to call this one P, Q, and R so we're not confused with our last one. All right, so now I'm going to do the perpendicular bisector of, and I'm going to do side PQ. Again, it doesn't matter the side you do, just pick one. I'm going to make my compass more than halfway. Do my 2 half circle marks, my arcs, and I'm going to draw, I hope, my perpendicular bisector. Ah, lovely. Okay, so I'm going to do the same thing on the other one. Again, I'm going to take and put my point on this time. I'm going to do PR. And I'm going to make sure my pencil is more than halfway. And do my 2 semicircle arcs. You guys will be pros at this perpendicular bisector by the time we get done, if you're not already. Again, using I can see my 2 pink arcs. This is why you see that I use colors, because it's going to be very easy to get lost in all these arcs, whereas if everything was in one color, it gets a little confusing. Okay, so now we can see, same thing as last triangle. We have 2 perpendicular bisectors, meaning that, when it does that, here between P and Q, and here between P and R, those points are midpoints, right? They're bisecting those 2 sides, and those are both right angles. So what happens here, again, notice your 2 lines intersect, but this time they intersect outside of the circle. So again, that's called the circumcenter. I'm going to grab my compass and see if it's going to be nice to me again. Okay, so again, I'm going to put my point on that intersection, maybe. Put my pencil on one of my points, and There we go. So you can see that if it's an obtuse triangle, we can still circumscribe it, right? You can see R, P, and Q all lie on the circle, but this time the circumcenter, since it's an obtuse triangle, lies outside of the circle, okay? So that's going to be the next thing we're going to write down, is that if it's obtuse, then the circumcenter is outside the circle. All right, outside the triangle. Obviously, it's not outside the circle. Sorry, guys, it's late. It's outside the triangle. All right, so finally, let's look at our right triangle and see what happens there. So I'm going to clear this out, refresh my page. And now you guys have compasses and are able to make these exactly right. I am going to hope that mine is, super close. I guess I could use my protractor tool here. Let me do that. There we go. Oh, well, is it going to let me? It would help if I had that turned on. That would be helpful. Well, gosh darn. There we go. All right, so that's pretty right. So we're going to call that a right angle. Let's get rid of that protractor. I wanted it as close as possible. So we know that this is the right angle. Right, and again, I'm going to call this, let's do LMN. And I'm going to do the perpendicular bisector of two of these sides. It doesn't matter which two sides. I'm just going to do the two legs, because they're easier for me to do. Actually, I'm going to do the left leg and the hypotenuse. Why not? Okay, so I'm going to do the left leg. So I'm going to put my point on L, make sure my pencil is more than halfway. I'm going to do my two half circle marks. I'm going to have to go to M. There we go. Oop, there we go. So there's my reference for the left side of the triangle. And okay. All right, so there's the one for the left side. Again, we know that point is in between L and M. It's the midpoint, and it's and it's perpendicular. Okay, so now I'm going to do from L to N. I'm going to do the hypotenuse just because I want to. Okay, go. Is it frozen on me? Oh. This isn't good. Put that back. There we go. Okay. Technology's great whenever it does what I want it to. Okay, from L to N. So I'm going to put my point on L. Make sure my pencil is more than halfway, so I'm going to have to open mine up quite a bit this time. Do my half circle mark. It's pretty big for this one, because the hypotenuse is the longer side, so it would obviously be larger. Okay, so looking at my two blue marks, I can see where those two intersect. So I'm going to draw my line through that. All right, there we go. Okay, so now I can see my two perpendicular bisectors are the orange line and the blue line. Now I want you to notice where those two lines intersect at. They actually intersect, gosh golly, on the hypotenuse, right? There's where they intersect at, right there, actually on the hypotenuse. And if we want to be real specific, they intersect at the midpoint of the hypotenuse. So let's make sure and check that indeed is the perpendicular bisector. The circumcenter. Again, y'all, it's late. I should be asleep. Okay, so I put my point on that intersection where my circumcenter is. Put my pencil on one of the vertices of the triangle, and it should indeed circumscribe the circle. So if you look where L, M, and N are located, they're all on the circle. The circle is going around the triangle. So for the last one, in a right triangle, the circumcenter is on the hypotenuse. Okay, so that's what I want you to know how to do today. I want you to know how to construct the circumcenter, how to construct the circle that is circumscribed about the triangle, and to be able to tell me where the circumcenter is located in an acute, an obtuse, and a right triangle.